For the final equation on the review, number 20, we again want to get the x by itself, but right now it's trapped inside the logarithmic equation. To get an x out of a log, I'm going to need to switch it to exponential form, but that log part has to be completely by itself before I start. So outside of the log equation here, notice I've got a 5 that's being multiplied and a 2 that's being added, so we need to get rid of those first. Plus or minus is the weakest link in PEMDAS, so we take care of that first. Bringing this down, this is going to give me 5 log of 3x equals 5 after we do the 7 minus 2. Now the log expression's still not by itself yet, so the next thing we're going to have to do is divide both sides by 5 in order to get that log expression alone. So now I have the log of 3x is equal to 1. Now, if I want to change from log to exponential form, notice that I need to know what the base is. Remember, if there's no base written, we assume that's the common log and it's base 10. It really helps me to go ahead and take a second to write that in because now it looks familiar. So when I switch it to exponential form, and again I'm doing that to get the x out of the log, I'm going to have 10 as my base, zigzag over here, 1 is going to be my exponent, equals whatever was left inside, which in this case is 3x. On the left, 10 to the first power is just 10, so I can simplify my equation a little bit there. And now to solve for x, I just need to get rid of the 3. It's being multiplied, so we divide each side by 3, and we get what my solution is for x in this problem. You can either write that as a fraction, 10/3, or you can write that as a decimal, which would be 3.3333 if you take it to 4 digits after the decimal. Either of those forms